First thing we need to do is say, okay, what class of compounds is it? Is it ionic, covalent, acidic, or organic? What category are we going to put this one in? Okay. So, Jay Breezy says it's ionic. Is that a question or a statement, Jay Breezy?
Yeah. I didn't respond.
Oh, I thought it was you. It was Connor. Okay, sorry, Connor. Apparently. Okay, Connor, why do you think it's ionic?
I don't really know how to explain it very well, but when you have the CC3 and then there was CO3 and then parentheses, it's 7x.
Okay, so he has something in the back of his brain somewhere that tells him, bingo, ionic, but he doesn't really know what that is.
Isn't it a metal bonded with a non-metal?
But this is not a metal bonded with a non-metal. I have, look, I have two non-metals here. I have, you have boron, which is a non-metal, and oxygen is a non-metal, so there's really two of them. It's not just a metal bonded with a non-metal, okay? It's got a little more than that. All right, Ben, what was your answer? Right. If we have a polyatomic ion in the formula, guys, if we have a polyatomic ion in the formula, it's got to be ionic. Well, I mean, in this class at this time, okay, there are actually times when that is not the case. You get into higher levels of organic and things like that, you're going to find there's times when you have organic compounds that include polyatomic ions. Okay? All right. So it's ionic. You've got to be able to classify it. So the two ways to know if you have an ionic compound is, and you were right about saying metal or non-metal, okay? If it's a metal bonded with a non-metal, okay, then yes, it's going to be ionic, or at least most of the time. And in this class, you can just about always count on that. There are times, again, higher levels of chemistry, you'll find out sometimes it's not even ionic, even in those cases. But if we have a polyatomic ion in the formula, in this class, at this time, you can almost always count on it being ionic, okay? So this is ionic, so we're going to use the ionic rule. So if we have a polyatomic ion, how do you name the polyatomic ion? Look on your test references, and the specific reference we're looking for is the common ions list. Okay, it does list polyatomic ions. It says polyatomic ions there at the top. So what we want to look for is some part of all of this that looks like something on here. Okay? I want to try to find something on here that looks like that. So what in this formula looks like something on here? Borate. Good. All right, so borate. Let's see, BO3. Borate, 3 negative. And that's borate. Oh, wow. Yeah, it's negative in it. Okay. All right, so let's see. We also have TC. Okay. And where do we find that one?
On the periodic table.
Okay. So if we look on the periodic table, then we should be able to find TC somewhere. Okay. And search. There it is.
Right there.
All right. So that's technetium. Yeah, it's kind of an alpha. Okay. So is technetium, does it have more than one oxidation number, or is this one? Okay. This is where you have to look for that. So technetium has a choice of 3 different oxidation numbers. I need to know which one to use. Okay, because I can't name it without it. Well, let's see. We have 7 3 negatives over here. So we're going to add we're going to have 7 times 3 negative, and we're going to add that to 3 times some number here. That's going to give me an overall 0 charge. This formula up here has no charge written in the upper right. If there's no charge up here, then the charge is 0. Okay? So we need an overall 0 charge when we're done. And Misha said the only number that works there is a 7 plus. That must make this a technetium. I've got to squeeze it in. I didn't leave a lot of space there. Technetium 7 borate. Okay, I'll rewrite it so it's a little neater here. Okay. You only use the Roman numeral when it's ionic and the metal has a choice of more than one oxidation or charge number. Okay, and you have to pick you have to figure out what the correct oxidation number is. Okay. Everybody got it?
How do you write straight without any lines?
How do I write straight without any lines? Practice. Yeah, Ben?
So why would that lose 7 electrons instead of just trying to get one more?
Say what now? How would it be 7 electrons?
Why wouldn't it lose 7? Why would it lose 7 electrons?
Why would it lose 7 electrons?
Instead of just trying to get one more.
Well, let's look. Okay, that's a really good question. Let's go back and look at technetium. Okay, technetium is one of the transition metals here. Let's go back to the periodic big periodic table. Okay, so here's technetium. All right. So let's go back to orbital notation, TC, and let's see, we got 1s, 2s, 2p, 3s, 3p, 4s. Okay, when we get to 4s, then we're going to drop into 3d here. And these have not 3 boxes, not 1 box, but 5 boxes. Yeah. Fill it up. 4p, or 3 boxes for that. And we're using the school bus rule, 1 electron in each box, and then go back and pair them up. Okay, then we're going to be, now we're in this row where technetium is. So this is 5s. And then we're going to be down in 4D here. All right. So I'm at strontium. I need 1, 2, 3, 4, 5 electrons. 5 electrons in this transition metal area. That's the D sublevel region. The first 2 columns here is S. The last 6 columns P. And this section in here is D. Okay? And so we want to put in 5 electrons. 1, 2, 3, 4, 5. Okay? Alright. Now let's just look and see about gaining more electrons. Alright? So 5s, and then we get back up to 5p over here, which are not, there's nothing in there really right now. Okay? So really, if I'm going to add electrons, I don't need to add 1 more, Ben. In the case of technetium, I need to add 5, 6, 7, 8, 9, 10, 11 electrons. That makes sense?
Right.
To fill up the valence level. So for technetium, it's a whole lot easier to get rid of 7 than to gain that many, right? So by getting rid of all these 7 electrons here, okay, then I have a full valence level. 4s and 4p are full. That makes sense?
Right.
Okay. So There's a lot of things about the electron structure we don't cover in this class. Theory, background theory, about stability and why it does the funny little things it does, especially with the transition metals with those different types of charges. Okay? But there are some basic patterns that we have talked about. You know, one electron in each orbital is more, in the d orbitals anyway, is more stable, things like that. We've talked about those things.